Hello, and welcome back to another journey through the cosmos. Did you know that 99.999% of ordinary matter is actually nothing but empty space? That means you, me, and everything we see in the universe are, at our core, essentially hollow. Or how about the fact that there is a particle out there carrying so much energy that scientists officially dubbed it the "oh my god" particle? Welcome to Universe 44, the sugar cube of humanity and the oh my god particle. If you have a passion for learning mind-blowing facts about the universe, you have likely heard or read somewhere that 99.999% of ordinary matter is empty space. If you were to remove all that empty space from within our atoms, the entire human race, all 7.8 billion of us, would fit into the volume of a single sugar cube. Now, if you are wondering whether what you just heard is actually true, the answer is both yes and no, depending on how much time you have to dive into the details. Let's look at it this way. In terms of physical size, the atomic nuclei and the electrons that make up an atom are incredibly tiny compared to the atom itself. According to Wikipedia, the diameter of an atomic nucleus ranges from about 1.76 femtometers for hydrogen to 11.7 femtometers for uranium. We also know that the nucleus is significantly larger than an electron. Meanwhile, the diameter of an entire atom ranges from about 105.84 picometers for hydrogen to 312 picometers for uranium. With a few simple calculations, we can deduce that the diameter of an atom is between 26,634 and 60,250 times larger than its nucleus. To put that in perspective, imagine an atom with a diameter of 100 meters, its nucleus would only be between 1.6 and 3.75 millimeters wide. With the nucleus sitting at the very center and the electrons orbiting at the extreme outer edges, we can technically claim that an atom is essentially empty space. By extension, you, me, the Earth, the Milky Way, and the entire universe are fundamentally hollow. However, if you take a moment to look a bit deeper, you will find that the empty space between the electrons and the nucleus isn't actually empty at all. According to quantum field theory, that region is filled with the electron field. This field surrounds the nucleus, neutralizes its electric charge, and occupies the space that defines the atom's physical size. So, now you understand why an atom is simultaneously empty and not empty at the same time. Moving on to the second point, if we removed all the empty space from the atoms, the volume of 8.3 billion people on Earth would fit into a single sugar cube. Let's do some math. An oxygen nucleus has a diameter of about 3.15 femtometers, while an oxygen atom has a diameter of about 60 picometers, which is 60,000 femtometers. This means the diameter of the oxygen atom is 19,047 times larger than its nucleus. Theoretically, and I emphasize theoretically, you could pack 6.9 trillion oxygen nuclei into the empty space inside a single oxygen atom. Why use oxygen as our example? Well, your body and mine are roughly 65% oxygen. For the sake of this video, let's assume the human body is 100% oxygen. Looking at the global population, the total mass of 8.3 billion people, with an average weight of 62 kilograms per person, is approximately 514.6 million tons. Assuming human density is roughly 1 kilogram per liter, the total volume of 8.3 billion people is about 514.6 million cubic meters. If we divide this number by the 6.9 trillion nuclei we can pack into that empty atomic space, we get a volume of 0.0075 cubic meters, or 75 cubic centimeters. That is roughly equivalent to the volume of a sugar cube with sides 4.2 centimeters long. It's a relatively large sugar cube, but you can still call it a sugar cube. As a bonus, a 4.2 centimeters block of matter isn't even the smallest size 8.3 billion people could be compressed into. If you had an infinite source of energy, you could continue to compress this half-billion-ton mass of matter until it reached a radius of just 0.0076 centimeters, or 7.6 nanometers. What you would have at that point is a black hole. Now, let's talk about the "oh my god" particle. On October 15, 1991, an atomic nucleus, likely a proton, traveling at 99.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 into Earth's atmosphere. It was detected by an ultra-high-energy cosmic ray observatory in Utah, USA. This single particle carried an energy of approximately 51 joules. To put that in perspective, that is equivalent to the kinetic energy of a 140-gram baseball traveling at 94 kilometers per hour. It is also enough energy to power a light bulb for about 1 second. That might not sound like much at first, but remember, we are talking about a single proton with a diameter of approximately 1/1,000,000th of a nanometer and a mass of roughly 1/1,000,000th of a billionth of a billionth of a gram. If you need more reason to be amazed, the energy carried by this superproton was 100 billion times greater than a photon of visible sunlight. It was about 40 million times the energy of the highest energy proton ever produced by any particle accelerator on Earth, including the one built by Tony Stark, and about 20 million times the most powerful electromagnetic radiation ever emitted by an object outside the Milky Way. This is exactly why scientists named it the "Oh my God" particle. The Oh my God particle is an ultra-high-energy cosmic ray, and it was the most powerful cosmic ray ever recorded at the time of its detection. Before this event, scientists believed that such a high-energy cosmic ray could not exist, or if it did, it could never reach Earth. Yet, it clearly exists, and it clearly made it here. To understand why scientists were so skeptical, you first need to know what a cosmic ray actually is. According to Wikipedia, cosmic rays, despite the name, are actually atomic nuclei, usually protons, traveling through space at nearly the speed of light. This means that not only is the Oh my God particle fast, but all cosmic rays are incredibly fast. The Oh my God particle is just slightly faster than the rest. Cosmic rays are all around you. It is estimated that every square centimeter of your head is struck by a cosmic ray or a secondary cosmic ray, charged particles created when cosmic rays collide with atomic nuclei in the air, about once every minute. As you can see, we are perfectly fine. Computers, however, are a different story. In the past, cosmic rays frequently caused computers to malfunction by flipping a bit's value from 0 to 1 or vice versa. For a computer, a single bit flip can be a disaster. In 1996, IBM estimated that cosmic rays caused 1 error per month for every 256 megabytes of RAM in desktop computers. However, with the advancement of technology, computer errors caused by cosmic rays are no longer a major concern. Returning to our main topic, the energy of a cosmic ray depends entirely on the astronomical event that created it. The more violent and intense the event, the faster and more energy-rich the resulting cosmic ray will be. For example, a cosmic ray emitted by the Sun will certainly be weaker than one released during a supernova explosion. Following that logic, the most energy-rich cosmic rays should be released from a gamma-ray burst, the brightest and most energetic astronomical events known in the universe. The reason the scientific community thought the Oh my God particle couldn't exist, or couldn't reach Earth, is twofold. First, as an extremely powerful cosmic ray, it would have to be created by an astronomical event more violent than any ever recorded, occurring in some distant corner of the universe so far away that humans might not even know it exists. However, if the Oh my God particle originated from a distance of several hundred million to a billion light-years, its massive energy would surely have been dissipated as it interacted with photons from the cosmic microwave background. For those who don't know, the cosmic microwave background is simply the leftover electromagnetic radiation from the extremely hot and dense period of the universe immediately following the Big Bang. Second, if the Oh my God particle didn't come from a distant location, it must have come from a source within or near the Milky Way, meaning within about 100 to 200 million light-years of our galaxy. However, an event massive enough to produce such a particle so close to us would certainly not have escaped the notice of human observatories in 1991. To this day, the true origin of the Oh my God particle, one of the most powerful and illogical cosmic rays ever recorded, remains a great mystery. As a final bonus fact, if a photon of sunlight were to race the Oh my God particle, the photon would technically win. However, it would take 215,000 years for that photon to gain a lead of just 1 centimeter over the Oh my God particle.